Hello students. Today we are going to discuss about class 12 physics. Now, as you know that in physics we count the unit, not the chapter, because under unit only there are many chapters. Okay? So, as you can see, unit 1 it is electrostatics. Okay? Now remember one thing, in electrostatics there are two chapters. First is electric charge and field, and second is electrostatic potential and capacitance. Now these two chapter, including this chapter, it consists of 8 mark in NBSE syllabus. Remember one thing, before you proceed with the derivation this and that, your concept need to clear about that particular chapter. And today class is only about introduction. Okay, so today only we're going to discuss about electric charge. What is electric charge, how it behave, what are different type of electric charge. Is it clear? Before we proceed with that, I want to tell you about electromagnetism. Remember one thing, students, electromagnetism is a very vast chapter in physics, and it consists of two branches, electrostatics and electrodynamics. Now electrostatics means what? As you can see, charge at rest. Charge at rest means what? They are not moving, they will be stationary, they are at rest position. But in electrodynamics, charge in motion means the charge will be moving. See, this one, charge in motion, you'll get in chapter 6, 7. Okay, now today class we're going to discuss about only the charge, how the charge behave, different type of charge. Okay, now the first question come to your mind is what is charge. See, charge is very simple. Charge are made of atoms. What's atoms? I hope you've learned in lower class. Suppose this is one atom, right? At the center of the atom, what's there? Nucleus. Nucleus made up of what? Your proton and neutron. Here, what's the outer shell? You'll get electron. Is it clear? So, actually, charge are made up of atoms only. Clear? So, atoms are made of what? You know, electron, proton, and neutron. At the center nucleus, there nucleus made up of what? Proton and neutron. Now, second is charge are intrinsic property of matter. See, intrinsic means what? Intrinsic is something which exists in its own. Okay, those don't depend on other. Clear? That's called intrinsic property of matter. Now again, is charge always come with mass. See, remember one thing, wherever there is charge there will be mass. I hope you know what's mass. You know already these things. Okay, now always remember one thing, there are two types of charge. One is positive charge, one is negative charge. See, negative charge we say electron, positive charge we say proton. Is it clear? Now see, remember one thing, if two charge, suppose two similar charge come together, suppose plus plus, what they'll do, they will repel. I hope you know repel means moving away from each other. And if we get opposite charge, minus plus means electron, proton, they will attract each other, they will come close to each other. So similarly, the last point say that charge is the property of electron and proton due to which they exert force on each other. Obviously, see, this electrons are negative, this proton are what? Proton are positive. So negative positive, what they'll do, they will attract each other. So that is charge. Now one thing, suppose if you want to charge a body, okay, how can you? Either by donating an electron or taking the electron, right? Suppose if I donate the electron, so what will be charged in my body? If I donate, then my body will be what? Positive. I hope you know these things. And those who are getting the electron, they will be negative. If we donate, positive. If we take, we are negative. Is it clear? And always remember, charge always come with mass. So wherever there is charge, there will be a mass. Okay, so these are about charge. Now this point is charge is scalar quantity. In class 11 and in class 9 you have learned that vector quantity and scalar quantity. What's vector? Vector means which have direction. Scalar means which does not have direction. So charge is scalar quantity which does not have direction. Now next point is the unit of charge is coulomb. COULOMB, coulomb. Now what's the unit? Suppose example, what's the unit of speed? Meter per second. What's the unit of acceleration? Meter per second square. So like similarly the unit of charge is coulomb. Okay, now it's denoted by a symbol q, small letter q or capital letter q. Is it clear? I hope you're getting what I'm saying. Now what's one coulomb? See, you have to know what, I hope you know what's coulomb. Coulomb is what? Is a unit of charge. Now what is one coulomb? One coulomb is equal to the quantity of charge that passed through a cross section of a conductor in 1 second given a current of 1 ampere. See, suppose this is a conductor, one conductor, right? Clear? Suppose here 1 coulomb of charge is flowing in 1 second. In 1 second, that is 1 coulomb of charge is flowing in 1 second. But remember one thing here, the current should be 1 ampere. What's ampere? Class 10 you've learned these things. Ampere is the unit of current. Is it clear? So what's one coulomb? One coulomb is simple nothing that whenever a charge flow through a conductor in 1 second, and remember one thing, in that conductor the current should be 1 ampere. Clear? See, by this formula, Q is equal to IT. Q is the charge, I is the current, T is the time. Is it clear? Now what's the value of charge? See, value of charge is 1.6 10 to the minus 19 coulomb. Remember one thing, why I wrote plus here and why I wrote minus here. Remember one thing, plus is for proton and negative is for your electron. So these are the value of charge. Is it clear? Now your next is, see, your next is charge is independent of speed. Now what is it? See, charge is independent of speed. If the speed of the charge is this high, low, whatever flowing, right? We cannot say like that exactly, but just for your understanding I'm saying like that. See, then charge will not depend on the speed, but mass depend on speed. Remember one, if you're running, okay, if you're running, suddenly the mass keep on increasing. Clear? Now that's why mass depends on speed, but charge does not depend on speed. Always remember these things. Is it clear? Now what do you have to know? What is charge? Charge is nothing. Is a made of what? Atoms. Is the intrinsic property of matter. Is it clear? Or is a force between an electron and proton. So you know that same charge attract or repel. Like positive they repel, moving away from each other. Opposite charge, negative positive, they will attract. Now next topic is your conservation of charge. I think in the other class 11 you have learned that what's conservation of energy. I hope you know. Same, conserve of charge. Conserve of charge say that energy cannot be created nor destroyed. It's simply transferred from one form to another. Is it clear? So I wrote here the total charge in an isolated system is constant. What's isolated system? Suppose this is one, this is called system. Example, this is a system, right? This is the surrounding, right? In thermodynamics we learned that. So isolated means which a body, where a body will not get disturbed from the surrounding. No, clear? So conservation of charge said the total charge in isolated system here, clear, will be constant. Suppose here charge is here 3 coulomb example, here 2 coulomb example. So why I wrote coulomb, you know, coulomb is the unit of charge. So here 3 coulomb 2 coulomb charge are there, so it will be constant if the is isolated. Clear, means heat, like in thermodynamics we have learned that, clear, heat cannot be exchanged between system and the surrounding. Clear? So I'm not going to say about thermodynamics, just for your understanding, because in thermodynamics we got in class 11, right? I hope you know what's conservation of energy. Energy cannot be created nor destroyed. It's simply transferred from one form to another. Now next topic here is come quantization of charge. Now many people they just get confused quantization of charges and that. But see, always try to learn in simple language because your idea, your concept need to be clear. Now, what's quantization of charge? What I wrote here, present fixed amount, continuation of charge. What it means? Present fixed amount. Suppose I'm giving an example out of physics, okay? So we're understanding. See, if you go to any showroom, right? Example, if you buy a shirt, whether the seller they will give you half shirt, never, right? They will give you full shirt, right? Then only if you want to buy the other shirt, they'll give you other shirt. Half is not possible, right? Means this is fixed. Clear? Argument what I'm saying. If you buy one shirt, you to buy other shirt. If you ask them give me half shirt, they will never give you. That is called fixed, right? And if you buy one shirt, again one shirt, again one shirt, is continuation or not? So this is called continuation of charge. Is it clear? What's quantization of charge? Means something which is present fixed amount. Is it clear? Now, the third point what you wrote is that the smallest charge that exists in nature independent, that is 1.6 to the power minus 19. I hope you know what's the goal. This one, this value is the what? Charge value, right, of electron and proton. Because as you know that for electron I'll write minus here, for proton I'll write plus. Again, in your notebook you will get that, or in your textbook you will get the definition like that. Charge exists in integral multiple of fundamental charge. Integral multiple. I hope you know what's called integral multiple, right? See, one electron, 2 electron, 3 electron. Is it clear? This is for proton, minus 1 electron, minus 2 electron, minus 3 electron for minus, right? For electron. Is it clear? So charge exists in integral multiple of fundamental charges. By this formula we can understand Q is the charge, and I wrote what? Integer. And clear? Fine. And this is the clear. Now your next will be how we can charge a body. Okay, how we can charge a body. There, see, actually in a textbook we got only charging by induction, but just I'm going to explain charging by conduction also. Now, what do I mean by charging by conduction? See, what I wrote here, with contact means if you want to charge a particular body, we need to bring the particular body in contact with the other body. Is it clear? Suppose look here. Here a body A and body B I'm using. Clear? Is it clear? Body A I wrote 4 electron example. Body B nothing I wrote, means suppose it's neutral. So there's any charge here. I said neutral, right? Now see. So these two bodies need to be contact, right, for conduction. Then only electron will flow from one body to another body, right? Now look here. I wrote here 4 electron. The next step they contact each other. See, this is A, this is B. They contact each other or not? Clear? Now see, electrons are distributed equally. Here 2 electron, 2 electron. But remember one thing, student, these things is not possible always. What you wrote here is not. If the size, shape and material of both the conductor are same, then only equal number of charge will be distributed. Is it clear? Equal number of charge will be distributed. Suppose this size and shape are different. Okay, so might be I've drawn whatever I've drawn here, might the shapes are not equal, but just assume that this is same. Okay, fine. Now if these two body shapes are different and material also different of the conductor, then equal electron will not distributed. Is it clear? Are you getting what I'm saying? So in conduction, what is charge by conduction? Charge by conduction, nothing is simple. This the two bodies should contact each other, then only the electron can move from one body to another, or can transfer from one body to another. Is it clear? Now in your notebook, the notes or textbook, you will get charging by induction. Now what is charging by induction? Charging by induction nothing means which is without contact, means the two body will not contact each other. Are you getting what I'm saying? Suppose this body A, this body B, clear? Now can you see actually it's a minus, so minus indicate what? Your electron. Now these two body will come close to each other but they will not come in contact. This is called charging by induction. Clear? Now see, suppose if we brought these two body close to each other, what will happen? Now here I didn't wrote anything, right? Yes or no? I said it's neutral body. Now tell me, in neutral body there will be any charge? Might be some of you are thinking neutral means nothing charge. Sorry, neutral means there will be a charge. Why? Neutral means what? Number of proton and number of electrons are equal. Then only we say neutral body, right? Means in this body, positive charge also there, negative charge also there. Are you getting what I'm saying? So this is a, again I am telling you, body A. Body A have electron, body B is neutral. But neutral, remember one thing, it have positive and negative both. Now if we bring these two body close to each other, now what will happen? See, here positive charge will come here, negative charge will come here. Why it happened like that? See, actually always remember one thing. Suppose this is a negative, right? The opposite charge will develop in the near end and the same charge will develop in the opposite end. So what will do? This is negative, this is positive. What they will do? They will attract each other. Are you getting what I'm saying? Similarly, if I draw a body here, if I put here positive, example positive here, right? Now if I brought a body near it, so body B, so this is neutral, what will happen? Here will be negative, here will be positive. Why? Because as I said, the opposite charge will be developed near the near end and same charge will develop in the other end. Is it clear? Now remember one thing, who is actually in this concept, right? In this topic, who is doing the work, proton or electron? Can you tell me? Protons are moving or electrons are moving, or what? Who are doing these things? Tell me. Actually, whole this working, right, actually is done by electron only, not proton. Why? Can you see here? It's written, I written mass of electron and mass of proton. Mass of electron is 9.1 10 to the power minus 31 kg. Mass of proton is 1.67 into 10 to the power minus 27 kg. So which one is the heavy here? Obviously proton is heavy. Electrons are not heavy than compared to proton, right? So that's why protons are very heavy. So electrons are doing all this working. Is it clear? So what we've learned here, charging by conduction and charging by induction. Again I repeat, charging by conduction means two bodies should contact each other, they should touch each other, then only the charge can flow. Charging by induction means the two bodies will not come in contact with each other, but still then charge will flow, right? So these are some basic things about this chapter, about charge. What's the, again I repeat, what is charge? Listen carefully. What is charge? Charge is made of atoms. What's atoms? Atoms are made of what? Electron, proton, neutron. So in atoms, what is there? Electrons and protons. Because electrons and protons are same charge, opposite charge. Opposite charge. What they'll do? They will attract each other and they create a force. That's also electric charge, right? Clear? And also remember one thing. Electron, electron. What they'll do? Electron, electron means is negative, positive. Electron, electron is what? Negative, negative, right? So they will repel. Same charge, repel. Same charge, repel. Opposite charge, attract. Clear? So please go through, this is the concept of the charge, okay? How charge behave. Clear? What are type of charge? So you have to know how many type of charge are there. Two type of charge are there. One is negative, one is positive. And what's the value of charge? for proton means positive is 1.6 10 power minus 19, and for electron is minus. For electron, right, minus 1.6 10 power minus 19 coulomb. So what's coulomb, you know, is the unit of charge. So student, just go through. On the next video we'll discuss about Coulomb's law, torque, electric dipole. Okay, so study hard. If you have any doubt, please ask me. Okay, thank you.